Good morning and welcome to the Copenhagen Developers Festival. And I always love the thing like I'm welcoming you. Most of you live here, right? And I don't. So I'm welcoming you to your hometown that I just got to yesterday. But this is fine. It is a great time to be here. This is an awesome event. It's lovely being here in Denmark in summer. It's awesome being in this part of Denmark. It's a fantastic venue. We got 3 days of absolutely awesome stuff lined up for you. We've got panels, we've got content, we've got music. We got maths. Tonight on this stage, we're going to have Matt Parker doing stand-up maths. And just to kind of warm up for that, I thought we'd kick off with a little talk about statistics. Because who loves statistics? It's all right, you're among friends, you can admit it. So these are all the people who are here at the festival. And 95% of the people who are here are professional developers. I know that because I built the system which sold you all your tickets. I know all your job titles. Now, there is a thing called Bayes' theorem. You folks heard of Bayes' theorem? It's about statistics, because human beings aren't very good at probability. Because you get an event like this, 95% of the people who are here are developers, right? Because that's the kind of people who come here. Now, let's imagine that you are chatting to a random person you met in the hallway who's wearing a big stupid hat. Now, do you think, now, planet Earth as a whole, the entire human species, big stupid hat means maybe triples the likelihood that the person you're talking to is a Texas ranch hand, right? Do you think that's true here? No. Because 95% of the people who are here are developers, and the hat has nothing to do with that. So folks, over the next couple of days, you're going to talk to a whole bunch of people, and if you get that little voice in your brain going, this person does not look technical, I should talk to someone who looks technical, you probably just don't understand the probability. And if somebody comes up to you, and they do that thing of like, you didn't look technical, send them to me. Because I run a friendly poker game. And we love meeting people who do not understand the way probability works. Now, quick show of hands. Who was here last year? And now, who is like, it's your first time at this festival, but you've been to like conferences and meetups and big tech events, you've done all that kind of stuff, yeah? Excellent. This is not for you. This is for all the other people. It's for people there with their hands down. Because this is scary. Like, if you've never done anything like this before, you're looking around going, these people all know each other, and I don't know anybody, and this is really frightening, and I don't know who to talk to, and I'm just going to go and hide, and I'm going to eat lunch by myself and everything. Yeah, I know it's scary. I'm going to give you some tips to get the most out of your time here over the next couple of days. So, first of all, the best way to start a conversation with nerds, ask them what they're working on. Hey, what are you working on? We love talking about the stuff we're working on. Great way to get conversation started. 2, the speakers, folks like me, the ones up here with the microphones and the PowerPoint clickers, we're the biggest nerds of all. Come and say hello. Ask us questions. Talk to us. Ask us what we're working on, because you won't be able to stop us talking about that kind of stuff. And 3, I want to tell you about a little thing called the Pac-Man rule. Now, when you're standing around at the expo hall or at lunch or, when we're having drinks afterwards, you get a couple of people, you're getting along great, you tend to form a little circle. And the little closed circle, that kind of sends a signal, like, no, this conversation's full, there's no room for you here. So if you're standing in a circle, think about it. Leave a gap, like Pac-Man's mouth here. You leave a gap in the circle, that sends a signal, hey, come and join us. Come talk to us. We're friendly. We want to hear about you. And when you join the circle, you widen the circle a little bit. It's a great way of making people feel welcome, joining new conversations, meeting new people, talking about geeky stuff. And on that note, let's geek out for a little while. Now, for as long as I have been working in technology, there has been a trope of people trying to hire Rockstar programmers. And you could go on IT job sites and search for the word Rockstar and find Rockstar JavaScript, Rockstar Senior Front-End. Because, nothing says Rockstar like a senior Java developer, right? Like, this is totally a thing that we've got going in our industry. And then about 6 years ago, Paul Stovell went on Twitter one morning and said, to really confuse recruiters, someone should make a programming language called Rockstar. Someone. Now, to understand what happened next, we are going to do a little whistle-stop tour through the entire history of computer programming. We're going to start, so the 1930s, we had the first mechanical and electrical calculating machines. This is an IBM 405 machine from 1934. Then during World War II, Alan Turing and his team, Bletchley Park in the UK, they built one of the first proper computing devices. But these things weren't reprogrammable. They could run programs, but to change the program, you switched them off, and you unplugged all of the wires, and you moved the components and changed the gears, and then when you plugged them back in and switched them on, that was the equivalent of running your program. And if you were lucky, it was going to work. 1946, University of Pennsylvania in the United States, ENIAC, the Electronic Numerical Integrator and Calculator. Now, this said, hey, I'm the first programmable computer, and the rest of the world kind of went, well, you're not really, are you? Because you don't have any memory. Now, it could run programs from punch card. So you had one stack of punch cards with your program, another stack of punch cards with your input. They ran it all through the machine. But it wasn't really programmable in the sense that we'd recognize. The first computer that did that was this. This is the Manchester Baby. It was built at the University of Manchester in England in 1948. And the first electronic programmable computer with memory. Now, I actually took this picture. This is a replica at the Museum of Science and Industry in Manchester, and they've got a working replica of Baby, and it is really cool and impressive and big. And they put Baby in the corner. Like, somebody here has not studied the classics. Now, the earliest computers, basically, they had memory that just stored numbers. And so the only way to program them was you had to know that, okay, so which number is the add instruction on this computer? It's F2. And then you'd give it the things you wanted to add together. And shortly after that, someone went, you know, it would be a lot easier to remember how to do this if instead of remembering F2, we could just call it add. That's quite a short word. We can do that. And so assembly programming was invented. We got any assembly coders out there in the crowd today? Because, yeah, assembly never went away. Assembly is programming with all of the safeties turned off. Assembly is the machine. It doesn't do what you want. It does exactly what you tell it. And if you get it right, you can get every last nanocycle of performance out of that device. If you mess it up, what does it look like when assembly crashes? It could be anything, right? It's completely, no checks, no balances, no type checking, just boom. Now, the next installment in our story comes in the 1950s. It's this guy, John Backus. And John Backus, a lot of the early computers were used in science and engineering because scientists and engineers do a lot of calculations. And scientists and engineers, they don't want to write in assembly. They don't want to write in machine code. They wanted to write formulae because that's what they're used to doing. And John was working at IBM on calculating ballistic trajectories for missiles and things. And he didn't like writing machine code. He went to his boss and he said, boss, I got an idea. What if we built a thing that could translate the formulae so that we could write formulae and then the computer would interpret them? What if we built a formula translator? And his boss went, good idea, John, go and do that. Now, Fortran is remarkable to me for three reasons. One, it was the first programming language, but we don't really care about that. Two, Fortran was a spec before it existed. Fortran was a specification in 1954. The manual was published in 1956. You couldn't get Fortran until 1958. So you had 2 years when you could read all about it, but you couldn't actually use the thing. Now, I'm kind of jealous of John and his team because they were the only people in history who didn't have this problem. They didn't have to choose a language to write Fortran in because there weren't any. And so they had to hand code it in assembler. Everyone else since then has been like, what should we use to build our new language? I don't know. We should do it in JavaScript. We could do it in Fortran. That would be funny. Now, we're going to bounce forward through the next couple of decades because there were all kinds of important programming languages like Lisp and Prolog and Haskell and all these kinds of things. We're going to fast forward to 1972, the year that gave us Snowball, Smalltalk, C, and one of the most influential programming languages that has ever been created, Intercal. Intercal is short for Compiler Language with No Pronounceable Acronym. It was created by Don Woods and Jim Lyon at MIT in 1972, and it was a pitch-perfect piece of comedy. Intercal didn't exist. Intercal was a manual. It was a documentation for a fictional programming language where all the output instructions were in Roman numerals, and it didn't have any sensible arithmetic. It only had 2 bitwise operators. It had a come-from instruction instead of go-to. It had no operator precedence because they wanted it to be unprecedented in every possible way. Now, there are 2 things about Intercal which are relevant to the topic of this presentation. One, it was just a manual. For 20 years, Intercal existed as photocopies of this pitch-perfect parody piece of technical writing. The other thing, as I was looking through it, doing the research for this talk, I noticed page 13 of the Intercal reference manual. intercal, if you wanted to exit your program, you had to say, please give up. If you didn't say please, it wouldn't work. If you wanted to do nothing in intercal, the idiomatic intercal for a no-op, a zero operation, is don't give up. Now, that was also a hit single in 1986 for Kate Bush and Peter Gabriel. So I think that is the earliest example of actual song lyrics appearing in the documentation for a computer programming language. Now, this rattles along just fine for a couple of decades, and then in 1990, Eric Raymond sits down at his Unix terminal and implements intercal in C, builds a real one. This is the first example of something we're going to see throughout this talk, Rendell's law. It is impossible to design a programming language or feature so stupid that somebody on the internet won't eventually implement it. Mark Rendell, our Locknote speaker, he did a thing at Build Stuff a couple of years ago where he invented deliberately, hey Mark, he deliberately invented the world's stupidest programming language. And a week later, somebody had implemented most of it and put it on GitHub. Now, intercal kind of, ticked along for 20 years. Then 1990, when Eric Raymond implemented it, that was kind of the start of the web. A lot of people were getting online in the 90s. It inspired this kind of fresh round of enthusiasm for esoteric languages, joke languages, comedy languages, which has never really gone away. 1993 saw the invention of one of the most notorious programming languages in history. Now, I know we're mostly grown-ups here, but there's going to be YouTube of this up there, and there might be kids watching. Kids, BF stands for best friend. BF is a Turing-complete programming language that consists of an infinite tape, or conceptual tape, an infinite list of cells that hold 1 byte each, an instruction pointer, and a data pointer. Or a data pointer and instruction pointer. The entire language consists of 8 bits of punctuation. If you see that, that means you move the data pointer. If you see that, that means you move the data pointer back again. If you see plus, it means you increment the cell that the pointer's pointing at. If you see a minus, it means you decrement it. If you see a dot, that's a standard input. Read standard in into the current cell. That's standard out. And in the square brackets, one of them is a conditional jump to the right, and the other one is a conditional jump back again. That's it. The BF interpreter is 240 bytes. It is the ultimate exercise in Scandinavian minimalism as applied to programming language design. That is the complete grammar. And because this made it possible, this kind of validated the idea you could build a Turing-complete language in 8 characters. You just needed 8 instructions. There is a whole family of languages out there now which are known as the Turing tar pits. Because all you need to do is think of 8 things that are funny in your domain, and you've got a language. We got any Discworld fans, any Terry Pratchett readers out there in the house? Have you heard of the programming language Ook? Ook, this is Ook. Ook is based on the librarian from the Discworld's Unseen University, and this is how you write Hello World in Ook. Actually, no, hang on. There's a bug in this program. Anybody spot the bug? No, of course you can't spot the bug, because Ook is a stupid language. Because the design of the language is wonderful and funny, but programs written in the Turing tar pit languages, they are just meaningless walls of nonsense. But Turing tar pits are not the only esoteric languages in town. Now, how many of you folks have written code in Perl? Got a couple of hands. Now, I'm genuinely interested in what the result of this. Compared to the number of Perl developers in the room, how many of you folks can understand Latin? It's kind of about the same. Like, yeah, dead language represent, Because Perl was very popular in the dot-com boom, the first one, like 25 years ago, and Latin was very popular in the Roman Empire. So one of them today survives because we have to be able to read the relics of an orgiastic age of excess, a dynasty that left their mark on the face of the earth, and the other one is Latin. And Latin is an interesting language. You see, in English, we have a sentence like, the cat eats the fish. And English has positional grammar. We have the subject, we have the verb, we have the object. The order of the words dictates what is actually going on here. In English, if we switch the order of the words around, we get the fish eats the cat. We haven't changed the words, we just shuffled them to a different order. This is known as positional grammar. But Latin has what's called inflectional grammar. So in Latin, felis means a cat. Felis means a cat that is doing something. That is the Latin word for a cat that is currently perpetrating an activity. And comedit is the Latin infinitive verb to eat. And paisem means a fish that is having something done to it. So felis comedit paisem means the cat eats the fish. Felis paisem comedit means the cat eats the fish. Paisem felis comedit means the cat eats the fish. If we want to change the meaning of the sentence, we have to change the form of the words that's used. We have to change the inflection to, instead of felis comedit paisem, we say filem, because M means something's happening to it. So filem is now the cat that something's happening to. Pisces is the fish that is doing something, and comedit still eat. And so these, top one means the cat eats the fish. The bottom two are the fish is now eating the cat. Now, what does this have to do with programming? Well, we take a little snippet of pseudocode like greeting equals hello world. You comfortable with this so far? And then we're going to print greeting. We all good? What about greeting print? It's like, no, you can't do that. It's the wrong way around. No. What if, look, we're going to sprinkle a little bit of syntax. You happy with it now? Because the sugar makes it all right. Yeah, we put the punctuation and you're like, okay, we can work with this. But what about this? What if we make a variable called print that contains the string hello world, and we create a lambda called greeting, which maps its argument to standard out.write, and then we can say greeting print. Now, this is a terrible idea, but most languages won't stop you doing this, because most programming languages use positional grammar. We can use the same identifiers to say, well, that's a function, that's a class, that's a method, that's a symbol, that's a variable, which means we can write code like this. I see people starting to look a little unwell. Like, that's not what that's for. You're not supposed to do that. We can basically, as long as we can fit it into the right point in the language syntax, we can do things like, hey, I want int1int28, that's going to mean system today. And I'm going to have a string called int32. And C# goes, well, yeah, that's fine. It's an identifier. There's no rule says you can't put that thing there. And so that's probably quite enough of that. Now, Perl was different, because Perl used prefix to indicate different kinds of variables. So in Perl, dollar always meant a scalar variable. So you could have $greeting, you could have print greeting. Now, the Perl language itself did not support $greeting print, but that's unambiguous, because print is obviously an operator, and greeting is obviously a variable, and so the engine that ran the Perl language, in theory, supported inflectional grammar. And then in 2001, Damien Conway at Monash University in Australia figured out how to write Perl in Latin. If you have to ask why, then the answer probably won't make any sense to you either. Damien Conway is brilliant. He's like, spends half his time doing really serious work on Perl, and the other half just doing the most bizarre things you've ever come up with. And what he'd figured out was that Latin grammar had enough kind of rigorous complexity in it to cover every single scenario that was necessary to write Perl programs. And so he literally wrote a thing that let you write Perl programs in Latin. So if you had last equals next, in Perligata, his Latin interpreter, this could be lasto da nextam, da, all of those would be valid and syntactically unambiguous. Now, I read Damien's paper when it came out back in 2001. At the time, I did not understand a lot of it, because he says things like, the solution that has been adopted is to depart from the second declension and represent hashes as the masculine plural nouns of the fourth declension. Is it? But I loved the idea. I absolutely kind of fell in love with this idea that you could extract enough syntax from a human language in another domain and use it to construct the rules of a formal programming language grammar. And so 20-something years later, I'd seen this tweet from Paul, and it just kind of burrowed into my brain. And back there, it met all of my years of experience working with Perl, and working with VBScript, and working with Ruby, and reading about things like Perligata. And then I was at NDC Sydney that year. I was in a bar. The perfect storm of esoteric languages occurred. I had internet, laptop, alcohol, and no one to stop me, because my friends were running late that day. And so I wrote a joke. That's all this was ever supposed to be, was a parody specification, like 2 or 3 screens full of Markdown, explaining the syntax of an esoteric programming language based on rock songs and heavy metal lyrics. Now, to understand where Rockstar grammar comes from, I want you to imagine that Perl and Ruby and VBScript walk into a bar with Bon Jovi and Motley Crue and Rat. And 9 months later, one of them has a really weird-looking baby. By the way, all you folks out there who had to argue with your boss to get a ticket to come here, I want you to photograph that slide and send it to them and say, we're learning about programming, boss. So I'm sat there, and I'm kind of thinking, what would it look like? How would you take little bits and pieces of 1980s heavy metal lyrics and turn those into a formal grammar? So I thought, well, variables and assignment, we've got int x equals 5, my string equals the message. Decision 1, yeah, it's going to be a dynamically typed language, and we're not going to have semicolons, because if JavaScript doesn't need them, neither do we. Decision 2, every piece of punctuation has to have an alias, which is a word. So x is 5, well, x is 5. It just is. That's what it is. And then I remembered a talk I'd seen Douglas Crockford give. Douglas Crockford invented JSON. He worked on the JavaScript team at Yahoo for a long while. And he did a talk called The Post-JavaScript Apocalypse in 2016, where he talks about all the ideas which are basically kind of such a big deal, everyone is frightened to talk about them in case they happen. And he asked that audience, he said, what's the longest argument you've ever had about whether you're going to use Pascal case or snake case or kebab case or camel case or all that kind of. He's like, you're all arguing because you're scared to ask for the same thing. You want variable names with spaces in. Now, when you invent a language in a bar, you can do whatever you like. So Rockstar has variable names with spaces in them. Now, it's not a free-for-all, otherwise it becomes impossible. What I said is, okay, there's simple variables that work like they do in Python and Ruby and everything. There's common variables have a prefix. So you can have my heart, an ocean, a kiss, his love, her eyes. See where we're going with this? And then proper variables have to have capital letters. So you can have variables called Dr. Feelgood and Black Betty and Billie Jean. Now, at this point, I'm kind of thinking, I think I can get this good enough to write FizzBuzz in. And to write FizzBuzz, you need to initialize variables to 3, 5, and 100. But numbers aren't very lyrical. It's difficult to sing digits. I thought, what if you can take any word you like, and we're going to count the length of the words. Modulo 10, and we're going to treat the word lengths as decimal digits. So the bit of your brain that wants to write songs can come up with rhyming couplets and things that express your heartfelt angst. And then the bit that's compiling it doesn't care what the words mean, it just cares how long they are, turns them into digits. Operators, arithmetic, well, you got A plus B, A times B, but you listen to people talk colloquially about arithmetic. They're like, oh yeah, the total it's the price with the tax. So there you go, we've got addition. We've got A of B, hey, what is it? We need the quantity of the product. We need the price without the tax. How speed is distance over time, so we got division there. But once you've defined these aliases, you can write arithmetic like a girl with a dream. It's a valid addition expression. Eyes without a face, fear of the dark, the moon over the city. It's all valid arithmetic, right? Math's never sounded so rock and roll. Pronouns. You bet your ass Rockstar has pronouns. For 2 reasons. One, there are some people on the internet who are afraid of pronouns. I don't think those people are going to have a very good time with Rockstar. But pronouns are a natural building block of human language. They're just an easy way of referring to stuff. If X is true, print it. How much ambiguity? You can all read that, right? It makes sense. Until your dreams are nothing, whisper them, tear them down. Pronouns in Rockstar refer to either the last variable that was assigned or to the left-hand side of the last comparison. So until your dreams are nothing, that's comparing something. Nothing is an alias for 0. Functions. How do you implement arithmetic modulus if you don't have modulus? Well, you do it with a loop that keeps subtracting. So you have a modulus. It takes a number and a divisor. And then while the number is greater than or equal to the divisor, you let the number be number minus divisor, and then you return the number. Or, now one decision I made is I thought, how do you end a loop? How do you end a block? And I thought, we'll do it with a blank line. Because in music, you have a verse, and then a blank line, and then a chorus, and then a blank line. This was a terrible idea, as we are going to learn a little later this morning. But you can also write this same function. Function is midnight, and it takes your heart and your soul. And while your heart is as high as your soul, you put your heart without your soul into your heart, blank line, and then you give back your heart, blank line. Good game. Friends turn up in the bar. I push this thing to GitHub. We all got and have a fun night out in Sydney. Before I left, I stuck it up on GitHub and I tweeted about it. And the internet got a little bit excited at this point. 24 hours later, it had something like 2,000 stars on GitHub. It had made the front page of Hacker News. It made Boing Boing. Cory Doctorow wrote a thing about it on there. There were people on Reddit saying nice things about it. Now, if you spent any time on Reddit, Reddit doesn't normally say nice things. That doesn't happen very often. There was just this massive flurry of excitement and people saying things like, I would love to be a certified Rockstar developer. That's a good idea we're going to come back to. Then I got an email a couple of days later from Classic Rock magazine. Now, Classic Rock is a proper music magazine that interviews like Metallica and Motley Crue and stuff. And they sent me this email going, what's this Rockstar thing everyone's talking about? Now, if teenage Dylan had known that I made it into Classic Rock magazine, they'd have been so impressed. And if they'd known why, they'd have been so embarrassed. But then, people started filing issues against the GitHub repo with the joke in it. And some of them were suggestions, like the arithmetic should go up to 11 and that kind of thing. And some of them were genuine questions, like your compiler, your specification has undefined behavior. And I'm like, why do you care? There's undefined behavior in the joke, so? And they're like, I implemented it. You did what? People implemented Rockstar. Randall's law strikes again. You can't invent anything so dumb that somebody on the internet is not going to go out there and they are going to build the thing. Now, there is a really interesting lesson in here about shipping, about the idea of the minimum viable product. Rockstar, first and foremost, is a joke. And in order for the joke to work, all we needed was a specification, a piece of comedy writing. Just like Intercal. Intercal was a photocopied manual for 20 years before anyone built it. Fortran was a written spec for a couple of years before anybody actually managed to implement the thing. If the thing you're doing is about awareness, it's about people reading it and understanding and getting where you're going with it, sometimes you don't actually need to build it. You just need to tell them what it's going to do. Turns out with Rockstar, this was good enough. There was this flurry of activity came out of it, half a dozen different implementations. One thing that I did not anticipate was the number of people with no technical or programming background who found Rockstar and wanted to try it out. I thought that was a surprise to me. Problem was, I thought this was going to be funny for about a week, and it kind of wasn't. And I thought it was going to be funny for a month, and kind of just, it kept ticking along, And all these people kind of joining the Discord server and saying, how do I try out this Rockstar thing? Now, what I had realized, there are two kinds of people in the world. There are the people who build esoteric language compilers for fun in a weekend, and there are the people who can build beautiful, intuitive user experiences. You know, the kind of things people with no technical background, they find it easy to figure out and work with. Now, this Venn diagram, it actually looks like that. With all the love and respect for the beautiful diversity of human endeavor, people who build compilers in weekends can't do UX. Like, it's just there's no overlap in those two human aptitudes. And, you know, I sort of found myself going, well, people are coming on the Discord going, hey, what's this Rockstar thing? I want to try it. And someone very helpful says, oh yeah, what version of Scala do you have installed? And they're like, what Scala? And I'm like, this is wrong. Like, you want to get the joke about the Bon Jovi songs, you shouldn't have to use Scala for that. Now, 2019, kind of January 2019, I sit down and I decide, we should have a version of Rockstar that doesn't need Scala, doesn't need Node.js, something you can open it in a browser on your phone and you can run it. And so I had to make a couple of decisions about where this project was going, because it clearly wasn't going to go away, but I also had absolutely no idea where it was going to end up. Now, there's a thing, any of you folks heard of something called the North Star metric? It's like a sort of corporate, how do you make decisions? You pick one thing you can measure. So like Airbnb, their North Star metric is how many rooms did we book last year? And Just Eat is like how many pizzas did we deliver last year? And I love that idea of you pick something simple and you say, that's it. If we get lost, the North Star just means we can at least move in the right direction until we figure out what's going on here. Problem is the North Star has kind of turned into corporate woo. Like you can do a 6-week training course with McKinsey about how to identify North Star metrics. And Rockstar is no place for corporate woo. And then I thought, well, hang on. Rockstar was invented in Australia. I was born in Africa. I'm not going to have a North Star. I'm going to have a Southern Cross. Rockstar's guiding principles. The things, anytime I'm like, what are we doing with this language? These are the four guiding principles of the whole project. If you can't sing it, you can't have it. Anything somebody wants to add to the language, you've got to be able to do it in a way that if you found it in like the liner notes for a Guns N' Roses record, it would just kind of fit. It would blend into the background. So everything you had, just like Damien Conway did with Perligata, if you can do it, you've got to be able to do it as lyrics. Comedy never justifies mediocrity. You folks know the movie Spaceballs? Yeah. It's a stupid Star Wars parody with dick jokes and things in it, but it's also brilliantly done. The special effects budget for Spaceballs was $22 million. The budget for Star Wars: A New Hope was $11 million. They spent twice as much money on Spaceballs as they did on Star Wars. Because when you're doing parody, Everything that doesn't fit has to be done on purpose. It has to be funny. It has to be a bit. Everything else just has to blend into the background. The reason Intercal worked is the bits that weren't jokes looked exactly like every other programming reference manual from the 1970s. You go and see like Weird Al Yankovic and his band live. They're some of the best musicians I've ever seen. They get every note for every song exactly perfect, because if they don't, the jokes get lost in the mess. Everything that doesn't fit has to be funny. Comedy never justifies mediocrity. One click. Anyone wants to play with Rockstar? One click, and there it is. Folks, I've been a student of comedy my entire life. I have never heard a joke so funny that I would have installed Scala to laugh at it. No, that's not a thing. And finally, I didn't ever want to get to a point where Rockstar went viral and I got a massive cloud bill. I wasn't going to pay out of my own money. I have no business plan. I still don't. I have no idea whether this will ever make any money at all. And so this had to be fixed cost. Even if, 100,000 people all decide they're going to try Rockstar this weekend, I wasn't allowed to leave me, paying a massive bill for it. So everything had to run client-side. Everything had to scale up with the number of people who were interested. So January 2019, I sit down, I'm like, right, I'm going to build a Rockstar interpreter that runs on the web that kind of ticks all of these boxes. There's one problem. I have no idea how to build an interpreter for a programming language. I have a degree in computer science, but that was a long time ago, and a lot has happened since then. And so I start looking around, and I start researching. I'm reading books, I'm reading papers, I'm reading websites about how to build a Lua interpreter in Scheme and all this kind of stuff. And I start asking people for help. Now, any of you folks recognize this? It's called the Angel of the North. It is a huge statue. It's about 54 meters wide, 20 meters high. It's stood up on a hill in the north of England, overlooking the main road and railway line that run in and out of Newcastle upon Tyne. So it's seen by millions of people every year. And I was doing IT help desk at the engineering company who built this. They didn't design it. It was designed by an artist, a guy called Anthony Gormley. But Arup was the engineering consultancy that were engaged to work with it. And I heard a lovely story about this. Gateshead Council, the client, they go to the engineers, and they say, right, this is what we're going to do. We want this massive steel angel. And it's up on a hill. It's got these huge outstretched wings. How do we build it? How do we make this thing stay up? And one of the groups of engineers they engaged, they went away, and they came back a couple of days later, and they went, we've got two recommendations. Don't put wings on it, and don't build it on a hill. I thought about this a lot in the early days of Rockstar because I would ask for help in programming forums, and someone would be like, why don't you use curly brackets? I'd be like, 'cause there's no curly brackets. You've got to be able to sing. They're like, why would you sing a programming language? This is why we have to teach art and music in schools, and literature and poetry and painting, because otherwise you end up with these people on the internet who are all brain and no heart, and they can solve any problem except why you should care. And so after a couple of kind of encounters with the programming language design genius purists, I kind of stopped asking for help quite so much, and I just figured it out as I went along. And by the end of the month, I had a JavaScript-based Rockstar interpreter that ran on the web. It's called Satriani, named after JS, Joe Satriani, the guitar player. And most of the code in Satriani was mine. But one thing that did come from the community that I thought was just, I want to acknowledge it and I want to celebrate it. The community created the Rockstar test suite. And what they had done, somebody on the internet had gone through every line of the joke that I wrote in the bar in Australia, and they created these little Rockstar programs which would exercise that feature of the language. And they did it in a way that's completely agnostic. Every fixture is a rock file and a rock out file. And so you run the rock file through your interpreter, and the thing you get out has to match the out file, and then the test passes. But the file names are brilliant. There's an array operator called pop, and so poprock is the file name. And let works as assignment, and so the test fixture for let is called let's rock, and the output fixture for it is let's rock out. Actual file name in the test suite, which I thought that was rather lovely. Now, by about kind of May 2019, Rockstar is just ticking along quietly. It's on the web. There's an interpreter you can play with. It's getting, between 5,000 and 10,000 visits a month are coming by this thing. I'm like, all right, that was it. That's finished. In October that year, we had a massive influx of people turning up on the Discord server asking questions about Rockstar and helping. We're like, where did all of you come from exactly? What just happened? Carnegie Mellon University runs a thing every year called PicoCTF. It's one of the biggest online capture-the-flag programming competitions for junior and aspiring developers. And in 2019, they had a whole round of PicoCTF based on Rockstar. 37,000 people took part in PicoCTF that year. And this little voice in the back of my head is going, if I'd known Carnegie Mellon University was going to look at it, I might have fixed a couple of things, you know. Nothing big. January 2020, NDC in London, I did a talk there called The Art of Code, which I know many of you folks have seen, that went online on YouTube and went on to get something like 3 million views that year. It was just unbelievable. Now, this was 2020. 1 million of those views were me reloading the video to see how many views it had now, because there wasn't a whole lot going on that year. A lot of folks are sat at home watching YouTube and stuff. But there's a little bit at the end of that talk where I talk about, you know, Rockstar and how it got there, and that got a lot of interest. This kind of ticks along. There's another spike, people showing up on Discord asking for help and stuff. Then in 2022, MIT, Massachusetts Institute of Technology, they have a programming competition. They have a capture the flag. And what they did, they had a Rockstar round, and they found as many real lyrics as they could. So somebody at MIT went through like Bob Marley's actual catalog and picked out as many lyrics from Bob Marley songs as they could that were syntactically valid Rockstar and used them to build a puzzle. And the back of my brain is going, MIT, the people with the moon landings where they invented Lisp and Ethernet, they looking at my thing. If I'd known they were going to look at it, I'd definitely have fixed a couple more things. And then last year, any of you folks done Advent of Code? Because last year, 2023, someone called CCC037 completed Advent of Code in Rockstar. They did every single day. They solved every single one of those puzzles in Rockstar. And that's the thing that got me. I was like, if somebody is going to work that hard, they deserve a better implementation of the joke than one that I hacked together in JavaScript in a couple of weekends when I didn't really know what I was doing. But something else had changed in the intervening 5 years. Because back in 2019, you know, one click, fixed cost, that means it's got to run in a browser, which means it's probably got to be written in JavaScript, because the state of the art with WebAssembly was not fantastic back in 2019. It was good, but it wasn't perfect, and it was still, you know, a lot of moving parts, a lot of rough edges. WebAssembly got seriously good, to the point where you can write code in any language you like, and you can build it, compile it to WebAssembly, deploy it to the web, and it's just going to run. But then November last year, I saw Eric Sarpalis from Microsoft did a presentation at the London .NET user group, which I helped to run. And he was talking about something coming in .NET 8, ahead of time compilation. After 20-odd years of C#, oh yeah, but you're going to need to install the .NET runtime, we are finally at a point where you can use C# to write your programs. I love C#. It is my favorite programming language without a doubt. And you can then compile it into just an ordinary binary that you can give to anybody, and they can go and run it on Linux or Windows or Mac OS or on the web through WebAssembly without them having to install the whole .NET runtime. So I can pick .NET because I like it, and that doesn't mean you need to do .NET. It just means you can run the thing that I got. C# used to be the Swiss Army knife of programming languages. With WebAssembly and ahead-of-time compilation, C# is the Swiss Army lightsaber of programming languages. There is nothing that it cannot do. Now, kind of gets to, you know, Christmas, beginning of this year, I'm like, right, let's do this. How hard can it be? We choose to do these things not because they are easy, but because we thought they would be easy. The programmer's mantra. I thought it would be relatively straightforward to port Rockstar from JavaScript to .NET. I have had many thoughts in my life. Few of them have been as wrong as that thought. Now, I want to shout out one open source project. There's a thing called Pegasus. It is a parser generator for .NET written by a guy called John Giertzen. This project would have been dead in the water without Pegasus, because we'll talk more over the course. Come and find me if you want to geek out about grammars. We're not going to go into it in the keynote because it's a little bit hardcore, but this is an absolutely fantastic library. Without this, like I said, it wouldn't have got off the ground. Now, what a parsing expression grammar allows you to do is to define a language by basically stacking regular expressions on top of one another until you have an interpreter. So I have a rule called string, say. And what it's going to do, this rule is going to scan my Rockstar program, or your Rockstar program. It's going to scan through the whole thing, and it's going to look for things that match that pattern. So it's going to look for, what do we want? We need a double quote, and then we need any number of characters which are not double quotes, and then we need another double quote. So that's going to match things like A and hello world and the empty string itself. And then a parsing expression grammar says, when you see that pattern, you run this code. And that code is embedded C# that's built into the grammar. Now, there is a problem with this, And it's a problem that has affected everybody who has ever tried to build an interpreter, which is when you build your own language, you need to build things like strings and numbers and booleans and functions. But languages already have that stuff. If you do new string in C#, do you know what you get? You get a .NET string. And I didn't want a .NET string. I needed a Rockstar string. And so I was thinking, all right, what can we do? So a lot of the textbooks say, well, you should call it string expression, or you should call it, this loop statement, function statement, while statement, number. I don't do that. I could qualify it every time. New rockstar.engine.values.string. I could say using aliases. And then I thought, hang on, I'm looking in the wrong place. I'm getting my inspiration from people who do computer programming. So I looked to Motorhead. The Rockstar type system uses the heavy metal umlaut to disambiguate Rockstar expressions from .NET expressions. This has only catastrophically crashed the entire project 10, maybe 15 times. But once you get the encodings figured out, it actually works really nicely. And one side effect that I found, by the way, I did this on a keyboard that doesn't have an umlaut key. So, like, ReSharper IntelliSense is like, he probably wants the null with the thing. I did make the decision it's always going to be the last vowel that gets umlauted, because that makes the IntelliSense work a little better. But this means I can have objects that implement .NET equality, just override equals, but then I also need Rockstar equality, and that's equals. Now, I think there's a convention here. We got equals. If I say equals, it means .NET. If I say equals and I do that, that's the umlaut there. So that's the Rockstar, the heavy metal horns there. And so, boom. New, not string, string, with apologies to German speakers. String, number, null, yeah, doesn't work terribly. Encoder works beautifully, just don't try and say it out loud. And when you match that pattern, you run this code. And then you build your entire language. So we got a pattern here, like a number it looks like this. We got a minus or a plus, followed by a sequence of digits. And when you see that, you emit a new Rockstar number with a umlaut on it. And then this whole pattern, you build these things up. You got rules like, okay, null, there's a bunch of different ways of null. You can have null, or you can have nothing, or nobody, or gone. And empty is empty, or silence, or silent. And then we have a rule that says, right, well, a constant, it can be null. If it matches that thing, then you emit the null instance. And if it's empty, then you emit the empty string instance. And then you just kind of stack these things up. So I got a rule called a primary. Primary is anything that emits a value, but you don't have to do calculations, so it's got no operators. So if you've got a string, you've got a number, you've got a constant, you've got a function call, you've got a variable lookup. Then multiplication, we've got star, or we've got times, or we've got of, so you can have the wings of the night and fear of the dark. And then you get the recursive self-referential rules that kind of turn your brain inside out until they click and you figure out how they work. Because a product is either a product times a primary, or it's a primary. And you're like, well, and what the parser is going to do is it's going to look at an expression like this. It's going to be like, right, what have I got? Okay, well, I know that's a times, and I know that's a primary. So what's the bit on the left? Well, let's take a look at that. Okay, what have I got? Well, I know that's a times, and I know that's a primary, because that's a number. So what's the bit on the left? Well, I know that's a times, and I know that's a primary, because that's a number. What's the bit on the left? Well, that's a number, and a number's a primary, and a primary is a product. So boom, I found a binary expression. Oh yeah, but now I've also found a binary expression. Oh yeah, but now I've also found a binary expression. And so you get this beautiful kind of recursive behavior. These things stack on top of each other, and your language kind of pops out of the top there. Now, at the other end of the extreme, so we got sums, we got products built out of sums, we got comparisons built out of sums. Then right at the top, a Rockstar program is either the end of file, so empty programs are valid, or it is a block followed by an end of block followed by a program. And then a block can be a statement followed by end of statement followed by a block, or it's just a statement on its own. And then a statement is, well, what do you want to do? We've got input, output, functions, loops, ifs, all these kinds of things. Insert rest of Rockstar here. Now, when it comes to interpreting this, the grammar is going to take your code and it's going to turn it into a thing called an abstract syntax tree, which is a big C# object that says this is what your program looks like. It doesn't tell you what it does, it tells you what it looks like. What does it mean? Now, something like evaluating an output expression, it's like, well, yeah, we're gonna see, what do you want to output here? Let's evaluate that, and then we're going to do so you see here, we got value.toString, because we need to turn it into the Rockstar string, but then we need to turn that into a .NET string so we can actually print it, and then we're just going to console write line it. Now, this kind of stuff is easy. Where it gets really fun building your own language is where you have to start evaluating operations and expressions. Now, if you worked in JavaScript, you'll know in JavaScript, 1 + 1 is 2, and true plus true is also 2, because obviously, and the empty object plus the empty array is obviously going to be the string object. But at this point, JavaScript suffers from a crippling failure of imagination, because if you try and subtract script from JavaScript, you get nan, not a number. And I'm looking at that, and I'm thinking, well, no, I don't want to return not a number. Where's the fun in that? I wanted every single operation in Rockstar, if at all possible, to return something, because somebody out there on the internet is going to find a way of using it. So let me take you on a little tour of some of the new features that we've added in Rockstar version 2. So this is the Rockstar interpreter we're running here now. What do you think Rockstar times 2 is going to be? Rockstar, Rockstar. How's that complicated? Like, surely that's obvious. What about Rockstar times -1? Gonna flip it, right? Because -1 inverts things, spells them backwards. What about Rockstar times 0.5? Rock! Yeah, give me half. That's what I want. What about Rockstar times -0.5? Rats. Because it's going to reverse the string and then take the first half, which is going to give you rats off the end there. What do you think Rockstar minus star should be? Rock. What about Rockstar divided by R? Now, when you say, like, OK, so 6 divided by 2, you're saying, hey, how many 2s are there in 6? So how many R's are there in Rockstar? 2. Well done, you got it. Rockstar divided by jazz? No, 0, because there's no jazz in Rockstar. So division starts out as a joke and ends up being quite a useful string search expression. You want to know how many of these things there are in those things? I got to string multiplication, and I'm like, I literally don't know what anyone would expect that to be, so we're just going to do like a matrix-style multiplication here. And then I realized afterwards that this means that if you multiply AD by C, you get the string ACDC, which is a clear sign that we are on the right track with the way that this grammar is going. Now, I mentioned earlier one of the bad design decisions that I made in a bar in Sydney writing a joke was to end blocks with a blank line, because in programming, you can have nested blocks. So you can have a loop that's got an if, that's got a loop that's got an if, which means you end up with code that has like 5 blank lines in it. And then if you take the comments out, it's really hard to tell how many blank lines there are here, how many times you're actually closing this block. And if you get it wrong, you've written an infinite loop, and they're no fun because they take a long time. And I was thinking, I need a better way of closing blocks. I need something I can throw in which it doesn't mean anything, but you can just like stack a bunch of them up in a row. And so I was looking, the C style, the curly bracket languages, they have like bracket, 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 and you're like, that's fine. And the Lisp and the scheme languages, they have this kind of thing. And I needed the idiomatic rock and roll equivalent of that. You can put as many "Oh Yeah, Babies" as you want in a rock song, and no one even notices they're there. By the way, there is a reason that Lennon and McCartney are fated as some of the finest songwriters of the last 100 years. It is not that song. So I thought, all right, that's it. End of block in Rockstar. We're going to plug a thing in there. Wakey, wakey, laptop. Come on, we've got a keynote to do. So an end of block is either an end of line, so you can still have a blank line, or it's yeah, or it's baby. And then I thought, hang on, what if O is going to close 1 block, but OO closes 2 blocks, and OO closes 3 blocks, and OO closes 4 blocks. And so I built this little rule here. This uses what's called a look-ahead. It's like, well, if you see an O, if there's an OH after it, then this O closes a block, but don't eat the rest. Leave that so that the next pattern matches that, and so you can close as many blocks as you want just by writing really, really long OOs. Now, there's one other feature that I really, really wanted to get into Rockstar 2. It's called ninja strings. And they're called ninja strings because they are awesome, and you're not going to see them coming. Because I wanted to be able to initialize string literals without actually having to say the word that was in the string. And so you can do something like, now Rockstar had arrays in about 2020. We added those as a sort of community thing. And instead of like push and pop for stack expressions, it had rock and roll. So you rock things and then you roll them back off again. And so I thought, so the night is silent, that gives you an empty string. And then I say, all right, we'll rock the night with 65. And I decided if you rock a string with a number, it's going to take the number, extract the code point, turn it into the corresponding Unicode character, and append it to the string. And you can stack these things up. So you can rock the night with 67, 47. Anyone really good at ASCII? So this gives you a way of building strings without referring to them directly. But we've also got the poetic literal syntax, right? So you don't need to write numbers to make numbers. And so you can write code like, my dreams hold diamond nightmares. Now, I got an idea. You folks want the stickers, right? You want to be certified Rockstar 2.0 developers, limited edition Copenhagen Developers Festival. Now, we're not just going to give these things out. There is a certification process. You're going to have to actually create some Rockstar code to qualify for this. And so what we're going to do now, I'm going to need your help with this next section. We're going to do a little call and answer. Now, I realize audience participation in Scandinavia early on a Wednesday morning, tough call. You think you're up to it? Yeah. Cool. So when I say your love, you all got to sing back your love. So we'll try one. Your love. Your love. My dreams hold diamond nightmares. Salvation holds the sea. The night holds silent echoes. Your love is meaningless to me. Rock my dreams like a love-struck smile. Rock my dreams with your love. Rock the night like a heartbreak missile. Rock the night with your love. Brilliant. Give yourselves a round of applause. That was beautiful. Now we're going to do a little code review here. So Diamond Nightmares, that's a 7, then a 0, so that's a 70. The C, 33. Silent Echoes, we got a 66. Meaningless to me, 122. Anybody who has the ASCII table in their head is like, I know where he's going with this, and I don't like it. I'm uncomfortable right now. 70 is capital F. That's exclamation point. That's a capital B. That's a Z. So that's an I. 122, your love, that's a ZZ. That's how you build FizzBuzz in Rockstar 2.0. Now, one click means I want this to just be something people can go and look at. So I built this whole rendering and construction pipeline. It compiles the .NET code to WebAssembly, then it minifies it, it strips out the unnecessary language, it builds it, bakes it into a binary, sticks it up on a website that all of you folks are going to be able to go and play with after the talk here. Now, the way this actually works, the web page has JavaScript running in it, and then that JavaScript talks to a background JavaScript process. Come on, you can do it. Now, the background work is there, so if you write an infinite loop in Rockstar, it doesn't freeze your browser. That's it. That's the only reason why we had to offload it, because JavaScript is still single-threaded. And so this thing, the worker.js, is then going to load, it's an 8 megabyte binary, which contains the .NET runtime compiled down to WebAssembly with the Rockstar interpreter sprinkled on the top of it. 8 megs gzips down to about 2 megs, which is good enough. Like, that's a quarter the size of every page on Facebook. And so I thought, that's fine. We can work with that in this day and age. And then that Rockstar WASM is going to run the Rockstar engine, which is going to interpret your program. And at some point, your program is going to try to console.writeline hello world. And at that point, I'm like, well, how do you do this? Because that needs to go over there. Like, we're 4 layers deep inside a background worker with a cross-boundary. Like, we've switched over into a different language here. Now, the real Rockstar developers in this whole thing are the people who implemented WebAssembly interop for .NET. Because if you look at the interpreter method that actually makes it happen, it's a task string. So you give it a program, it runs the program, gives you back a task which has the result in it. And then this thing here lets me take a JavaScript function that wants a string and inject that through 5 layers of abstraction. So that ends up just sitting there right at the heart of my Rockstar interpreter, waiting for the rest of the world to come along and write something. And so when you actually run the thing, when you pass your code through all these different layers, you get this kind of golden thread back out of the labyrinth that gets you back up to the JavaScript level runtime, which means I can do a hello world in there. I can drop that in. That's going to write that, and that's just going to come out there. Now, this is the kind of stuff. I love this. So when you look at the code and you're like, how am I going to make this thing work? Is this going to be the deal breaker? And then you're like, no. Somebody smarter than me already thought of this, and you put this on your code, and it just works. And so, folks, you can go right now. Now, this is not live yet. It was going to be live, and then I thought maybe it would be good to do what Google do and keep it in beta for about 15 years, and then one day we'll quietly take the beta off. So you can go to beta.codewithrockstar.com right now. You're going to be my beta testing group. So the next couple of days, play around with this. Go there, try out, play with the code, see what you can get it to do. Come and ask me questions. You've got brilliant feature suggestions. Come and have a chat and let's talk about it. And we're going to wrap up now, folks. Have an excellent couple of days. You're going to have a fantastic time here. We got really awesome people. We got great content, food, drinks, parties, music, Matt Parker doing stand-up maths. It's going to be awesome. But I'd like to close out now by performing what I believe is going to be the world premiere, unless you were sat here during the sound check, of FizzBuzz in Rockstar 2.0. Takes your heart and your soul, while your heart is as high as your soul. Put your heart without your soul into your heart. Baby, give back your heart. Yeah. Your dreams hold diamond nightmares. Salvation holds the sea. The night holds silent echoes. Your love is meaningless to me. You remember your part. Rock my dreams like a love-struck smile. Rock my dreams with your love. Rock the night like a switchblade missile. Rock the night with your love. Desire is a love-struck lady killer. My world is nothing. A fire is ice, the sky is crying, till my world is desire. Build my world up. At midnight, taking my world, fire is nothing. And midnight, taking my world, the sky is nothing. Shout my dreams with the night, with salvation. Take my heart, baby. At midnight, taking my world, fire is nothing. Shout your dreams with salvation. Take my dreams, baby. At midnight, taking my world, the sky is nothing. Shout night with salvation. Take the night, baby. Whisper my word. Folks, have an awesome week. We'll see you around. Come to say hi to people, chat about what you're working on, geek out, remember the Pac-Man rule, and I have a whole load of stickers down the front, so come and grab one of those. Thank you so much.